Hi, I'm Joe Petrowski, and I'm here with Shawn Tabrizi. We're both from Parity Technologies. So in this video, we're going to help you get familiar with the Substrate codebase. And as a Substrate developer, the most important thing to know is the runtime. And so the runtime keeps like all the logic of your blockchain that gets exposed to users. And Substrate comes with this collection of pallets called Frame that lets you compose your runtime. And you can write your own pallets to extend Frame, but you could also make a blockchain just based on a custom configuration of Frame pallets. So either way, you need to be familiar with the structure of a pallet and some of the special tools and concepts. So we're going to start with like a full directory walkthrough of like all the stuff that's around Frame, so you kind of know like what kind of support you have around this. And then we're going to go through like a really simple Frame pallet and just show you like all the concepts and the structure of this. And then we're going to take that concept and show something a little bit more advanced that you can do with it. So with that, I'm going to pass it over to Shawn to start going through the code.
Yeah, I think it might be good to first talk about the fact that, when you build on Substrate, what is it that you're actually building or compiling? And I think the answer to that is a node. You're building a blockchain node. And this node is something that you run on your computer. And if you're running a distributed system, people all around the world are also running the same software on their computers. And all these things are connecting and talking to each other to make a blockchain network. And so when you actually use Substrate, when you actually compile the final product, you get this executable, this node software. And this is actually what you find in this first folder over here called bin. These are the binaries, the executables which gets generated when you build on Substrate. You'll see in this folder there's two nodes. One is kind of a more full node, basically, one that has a lot more modules, is kind of used for our Substrate testnet. You also have a node template here. This is actually meant as kind of a starting point for new developers to be building their Substrate project. So it has a very minimal number of modules and basically allows users to basically get started building on Substrate more easily.
And if I remember correctly, like the node has pretty much everything in it.
Yeah, I think not everything, but certainly if we take a look just really quick, if we jump into the code, we can go into the runtime. This is kind of where all of the pallets are. And if we go here and we go to something called construct runtime, oops. We find it. You can see here, these are all of the different basically pluggable pallets that we have in this runtime. So this is on the order of what? Maybe like 20 or more. And then if we go look at the node template, you'll see it has a very similar structure. We can go to the node template, go to the runtime, and we go to the lib, and we go also look for the construct runtime. And you see here, it only has something like, 10 maybe, right?
Yeah, so like the bare bones, so you could start adding your own custom ones to that.
Exactly. And so this one, I think a lot of the other ones kind of have more like on-chain governance, has more the staking stuff. But here there's a really good like kind of a blank canvas for you to start building whatever you want.
Yeah, and these are a bit like out of context now, but like all of these pallets come from Frame. So for now we're kind of going around it, but like we're going to see that where these come from.
Beyond that, also we have some other utilities that get built along. But I guess the main thing I wanted to get away was that when you build a Substrate, that you're basically generating executable, and this is what this bin folder does. All right, and then you have the client. This is basically all of the crates and libraries that we need to build the Substrate client itself. It contains a wide vast set of, I guess, libraries, but I think you can see here some of them like the RPCs. So like, when you interact with your blockchain, you're usually doing it over a JSON RPC. So this has all the libraries for that. You can see there's database layers, CLI, obviously the thing that you're actually interacting with when you go into your terminal. What else is here? You have executor, which actually is going to run and execute some of the blocks. The state DB and stuff like that, which is actually managing the underlying database.
Transaction queue.
Yeah, exactly.
Key store.
So these are all the things that you would expect when you run this binary that are included into the client that you're running. And so these are all those libraries. We'll skip over docs. Obviously, these are docs. We'll skip over frame for now. We'll go jump to primitives. And so then when you're setting up a Substrate environment, a blockchain environment, there are a set of primitives that you need to establish for how your blockchain should interact. So one of the interesting things about Substrate is that in general, it keeps things very generic. And one of the way it does that is that it has defined all of these traits and primitives, which you can then implement. So I guess we can go to this a little bit later as well, but things like Substrate does not assume what kind of hashing algorithm your blockchain wants to use. Right now we're using Blake 2256, but if you for whatever reason are building a Substrate chain in the future and there are better hashing algorithms, or if you need something that's a little bit maybe less intensive, you can go ahead and choose that. And what we do is we define a set of traits, which basically say that whatever hashing algorithm you use have to have these traits. Like it needs to be able to hash an arbitrary string of bytes and create some kind of output. And you can implement those traits and basically use whatever hashing algorithm you want to use. And I think the primitives here describe a lot of the underlying traits and primitives that are used in Substrate. Some of them
it's like the opinions.
Yeah, exactly. Some of them are more defined. Some of them are less defined, allowing you to put your own spin on things. But end of the day, this set of primitives is the language of your blockchain, basically.
Right. So in your runtime, if you say hash, you can, by implementing the hash function in the primitives, you can just in your runtime say hash. And if you decide to switch your hash function, just re-implement it in the primitives, and you're calling into that all the time.
Exactly. And yeah, so you can see there's a bunch of stuff. These are kind of more specific to the frame pallets that we kind of were alluding to. But you see we have things like consensus, some finality stuff with Grandpa. I guess some things about off-chain workers. Fragment is the algorithm we use in staking and in voting to determine the winning set of people. And then we have things like, I guess more storage stuff, transaction pool stuff. Again, these are the in this context, again, they're the primitives of using these different items versus kind of the actual client code. Yeah, and then test utilities, and we have some utility functions. My understanding of the utility folder is this is kind of a bridge. So what we try to do in Substrate, and we try to do in general, is try to keep everything separate so that we don't have these interlaced dependencies. So utilities is kind of a bridge where it connects different components like the primitives to frame or frame to client without necessarily having them hard-coded into it. So it allows things to be more modular and allows you to pull things apart more easily. But yeah, that's the high-level overview. And then finally, the piece that we've been alluding to the whole time is frame itself. And frame is in this folder is it is a framework for building blockchain logic, for building the content that goes into your Substrate runtime. It is very opinionated in the fact that if you're using frame, you're using a bunch of core pieces, things like the system, things like support, and things like executive. And these are all part of our way of we think that it's easiest to design the Substrate runtime. You don't necessarily need to use frame to build a runtime for Substrate. You can actually just use Substrate as a client which hosts some WASM interpreter and basically build your WASM code which satisfies the runtime APIs. Inject that into your Substrate client, and it would run the chain there.
And those are defined in primitives.
Yeah, exactly.
So basically, like with the client and the primitives parts, you can build your runtime completely on top of that, and you still are only building your runtime. You're not building like any of the RPCs or like database layer stuff.
Yeah, all the RPC stuff is handled for automatically with the client. But of course, that would require a lot of work to build it on your own. What's really nice is to be able to, use this framework that we've designed, which keeps things modular, which keeps things really easy to build new logic, and basically to like kind of mix and match the way that we're showing here in this construct runtime. Like, you can just basically go in, grab some pallet that you like, add it to your runtime, and just run. So that's kind of what the framework that we've designed, and I think we can dive more into it, right?
Yeah, let's go into one of them.
Yeah. So as I mentioned, there are what you see here actually is a collection of pallets built with frame, and then there are some folders here which are actually frame itself. So let's take a look at maybe what some of the pieces that are frame itself. Or actually, maybe would it be better to start off just looking at a simple pallet and then maybe working our way out?
Yeah, let's look at one of the simple ones.
Okay, cool. So I think a really cool one that is quite simple is sudo. So we already have this open, I think. And so sudo is one form of on-chain governance. I think governance maybe is not the correct term here. In the case of sudo, just like if you had sudo access on your computer, sudo access on a blockchain is basically admin access. It's the highest level permission. So this basically allows a user to be able to perform certain high-level actions on the blockchain, on your Substrate chain, that would not otherwise be able to be accessed by a normal user. And so if you take a look at this function real quick, what we see, if we can jump down, we'll see that every single pallet has almost the same pieces. So I'll actually collapse this a little bit. And you'll see here, this is actually the outline of basically every pallet you see in Substrate. There are some imports. There's this trait that we define. I won't go too much detail about here, but basically this is defining kind of the interface or the configuration traits for your pallet. And then there's these 4 macros, basically.
One thing to note here is that like the Substrate client crates are prefixed with SC, and you see that like nothing here will depend on SC. So this only really interacts with other frame modules, and then with primitives.
Yeah,
so
exactly.
This isn't really touching client at all.
Yeah, so that's the SP over here, the Substrate primitives. And that's exactly right. We want to keep those things separate. So if we take a look, so there's these 4 macros, which is I think the core part of using frame. You have declare module, which is basically a way for you to define all of the extrinsic functions, or like basically the callable functions into your pallet. We have declare event, which is basically a way to list the kind of events which can get emitted from your pallet when certain actions are running. We have declare storage, which defines all the storage items for your pallet. And then declare error, which can define any type of error messages you want to expose as a result of, let's say, a transaction failing for one of the function calls. And you can see that every single pallet will have actually these 4 macros. And together, the overall storage of your blockchain will be composed of all the different declare storages across all the different pallets that you use.
Right. And this kind of all gets assembled, and I think it's the support module.
So
for a system.
These macros are defined by the support, and we'll jump over to that I think in a little bit.
Okay.
So I guess I just want to give you finish the overview of the sudo module. So one thing you can really see is, let's start with the storage, is that the storage item is really simple. Right now there's basically just one key, which is an account ID, and this account is the sudo key. So there's one user who on your blockchain is God, is the admin. And then basically what we do is have a little bit of simple logic, which checks if this user, if someone calling the sudo pallet is this God user, this one we've set in our storage, then we can actually elevate the permission of the access. And we actually do this using a kind of clever mechanism called the origin. So so what we can take a look at here is that this is an example of a callable function, and this function is called sudo, and this is actually the main way that a user who has sudo access would actually be able to invoke their power. So you can see here we can take a look at the comments. It says authenticates the sudo key and dispatches a function with root origin. So we'll talk about origin in a little bit, but we'll kind of unwrap it. So you can see here the sudo function itself has 2 inputs. One is origin. Again, that's something that we've been talking about, and you'll see that every single extrinsic function has an origin. Origin is this idea or is a concept which tells your blockchain where the call is coming from. The other parameter is proposal, which is basically what is the call that wants to be made on behalf of this user using this root account. You can see here we're able to use the origin. Again, the origin is trying to determine where a call is coming from. So in this case, we know that the origin is signed, or we at least try to confirm the origin is signed, and we try to deduce who sent that message. And then if we can say that the sender is equal to the key that we have in storage, then go ahead and dispatch the call using a new origin, and then deposit an event that something happened. So you can see this function is actually quite simple. But what actually the magic is happening here is happening in this origin. So I think it's be important to actually deep dive into what the origin actually means.
Yeah, and I think I also want to cover here just a quick overview of decal storage because it does have like a funky syntax, and like what kind of features does that give you with this, or what is with this key thing?
Yeah, so declare storage, yep. So one of the things that you should know about macros, especially if you're familiar with Rust, if you're not familiar with Rust, then I think everything here is looking new. But if you are familiar with Rust, you might say that, okay, well, this is not valid Rust syntax. So one of the powerful things of macros, like this might be like a love-hate relationship, is that you can actually define your own syntax, which can be parsed and then rewritten into real Rust. So when you actually compile this pallet, all of these macros will actually expand to be much more code. In fact, with the sudo module, you can see here the overall line count is 218. I know for a fact if we were to expand this module, it would be over 1,000 lines long. So what we're doing for you with these macros is actually generating a lot of boilerplate code that you would otherwise not have to build yourself.
Yeah, so I actually opened the Rust docs here before we started. So like maybe we can just do a quick check on like what kind of functions come with that storage item.
Sure. So yeah, so basically when you define a storage item like the one we did key, you'll actually create something called a storage value. Oops. Here. Okay, and then we can actually take a look. This is from frame support. And you'll see that a storage value item, what we do is, we generate a bunch of boilerplate code for you. So for example, you might expect when you have a storage value, you can get the value, you can set the value, you can remove the value, all that kind of stuff, right? And whereas if you were writing this by hand, you would have to implement all of these functions, basically implement the entire trait of this storage item. We could do it for you automatically because we understand how to do it for you. So this storage value type basically has all of these functions expected for it. So things like get the value, does the value exist? I guess translate the value, that's kind of a more complicated one. Like put the value, mutate it, kill it, take it. And it expects all of these functions to be implemented. And what we actually do in the macro is implement it for you automatically. So with any of these storage items, we can actually call any of these functions automatically. And if we go back real quick, we'll see that we actually do that. So we have here a key. This is a storage value. It actually generates a bunch of code, which actually gives you access to all of these functions.
Yeah, this one line will expand and give you all of these functions along with it.
Exactly. And what you'll see is now we can actually access, just without even writing any code, we can access that key value by going up here and calling something like self key. This would actually be equivalent to saying key get. Actually, it would be T here because it's a generic. But those two lines are kind of interchangeable. They're kind of different ways you can access it. But you can see here, we basically accessed these different APIs, like this get here, basically onto this item that we've generated.
Yeah.
Right? Cool. I don't know if you wanted to jump in. I think I have on my GitHub an expanded version of the sudo module, and we can actually take a look at that real quick.
Yeah, sure.
Otherwise, we can.
And then I think we can probably do like a whole video just on decal storage, and because there's a lot of different types too, like linked map and double map, and
yeah, let's take a look. Okay, now I want to go to gist. Let's see if I can. If this isn't too hard, then I'll just give up very quickly. Sudo expanded. Perfect. Very first result. So you can see here actually, here is I think this is a little bit older than the file I showed you. I think the file was even smaller before. So what it will expand now is much more. But here's, if I were to expand all the macros, here's what the final sudo module would look like. And you can see here, looks a lot nastier. There are these kind of embedded doc comments. Things are kind of formatted a little bit weird. You can see that it is literally 1,000 lines of code or more. But if we actually look at the thing like key, what I will expect to see is a struct key right here, right? And this is what we actually are building when we define this storage item. So if we go back to the sudo, we go back to here. When I define this item key here, what it's actually doing is generating for me a struct named key, this first name. And then it's implementing all those other traits. So you can see here there's a function key, there's a function get, and get here is returning, is doing some more complicated low-level storage access to actually return to us the value. You can see here there's a take, mutate. So all of these things are being implemented for me automatically, things that I would have to otherwise write.
Right.
And so I think one perspective might be that macros can be difficult to learn a new language because you basically are defining some custom syntax, and it's hard to necessarily learn this when you're trying to learn Rust. But the other perspective to have is that, hey, we're actually saving you from writing hundreds of lines of code
for every single pallet.
By doing it this way. And this is really why we use the framework, right? This is why we designed it this way. It's actually from our experience, is the easiest way to kind of do things. Yeah, so I think that's a good place. So let's jump now back into origin. So again, if we take a look back at this function again, it was very simple. The logic here, it was basically one check: is the person calling the sender the pseudo user in our storage? And if so, what we can do is take the original origin and basically upgrade it to the root origin. And so what does origin mean here? So in order to learn more about origin, what we're actually going to do is we're going to jump into the system pallet, which is a part of frame. So unlike some of these other pallets like sudo, society, staking, any of those ones, these are all things built on top of the frame framework. But system is a little bit different. It is a pallet, just like the other ones, but this one is actually a core pallet, which is part of the frame framework.
Right, so sudo and staking kind of stand apart from each other, but they all have to use system.
Exactly. And so we actually take a quick look at the hints here. So again, one of the things we've done recently is renamed all of our crates to have good naming systems so you can understand. So SP is for primitives, SC is for client, and then of course we have pallet sudo. So this tells me, okay, this is a generic pallet. But if I go to system, you can see here it's actually called frame system. So we're basically saying here in the naming that this is a core part of the frame framework. You must use and rely on system if you want to use the rest of the frame framework.
Yeah.
Okay. And so one of the concepts we have, again, is this origin. And origin basically defines for us or tries to tell the runtime where a call is coming from. So if we actually go look at here, we can actually find raw origin, the definition of that. So here's the origin for the system module. It's this enum. So basically, enum can be one of these options. And in this case, and you can see the different options. One is root. The system itself as ordained this dispatch to happen. This is the highest privilege level. So imagine this is like, the blockchain itself is saying something should happen, right? There's a sign. This is the most average origin. So whenever you have a transaction on the blockchain, you're sending a signed message. And the blockchain can basically verify that the message is signed, uncover who the account ID is, and basically assign an origin of it's signed by this account ID. And then finally, we have an origin of none. And this is kind of a more complicated origin. I'm not sure how well I'm going to be able to define it here, but basically you can have a message or coming from the outside world, which is not signed, and it has no known origin. We call this an inherent extrinsic.
Yeah.
This is used, I think the best way to use it, to talk about it is that it's used in the timestamp palette. Basically, we have a separate palette here, which allows the block producer to define to say what the current time is. Now, the thing about time is it's quite arbitrary. It's quite abstract. Like
you can't agree on it.
Yeah, you can't agree on it. My computer and your computer are never going to have the exact same time. It relies on many different variables, which can never quite be in sync. Not quite deterministic, right? But time in general can be relatively close, right? Like, so if the time on a blockchain, and you have a blockchain which is producing blocks every 6 seconds, is within 1 second of time, I think that you're pretty much good enough. Maybe even lower than that, right?
Yeah.
And so what we're allowing here is we're allowing the block producer to basically state while they're producing the block what they state the time would be, and this actually comes as an inherent extrinsic. For a number of reasons, it's this, but the main one kind of being, you can think about it that this inherent extrinsic needs to be validated not based off of the fact that it's signed by a specific account, but based off the content itself. And so you having some timestamp which is signed by a user really doesn't mean anything. It doesn't matter that this person says this is what the time is. That you as a person ingesting the block should validate that the timestamp information being sent to you is relatively close. So when you're importing the block, you should take a look, like, is this time being put on the block
reasonable.
Correct? Yeah, reasonable relative to the other blocks, relative to the time that it is right now, all that kind of stuff.
Yeah. So I think like anything that gets dispatched with a none raw origin, it's usually like it needs its own custom validation logic.
Yeah.
Whereas something that's sent with like a signed origin, it's kind of valid because it's signed.
Yeah, exactly. And then you can think about it. Yeah, it's valid because it's signed for a number of reasons. One, let's say that the transaction did something, let's say, bad for the economic system. Well, it's a signed message, so we know who to punish.
Right.
Great. Let's say that the message itself has come some kind of spam. It's a signed message, so we know who to charge a fee to, right? So all these kinds of mechanisms, on a signed message, there's a lot of ways you can inherently basically ensure signed messages behave well in your system. Whereas there is this concept of these unsigned messages, these inherent extrinsics, which need its own validation logic.
Yeah, so we could probably do like a whole other video just on different types of extrinsics and stuff. Let's get back to like the root origin is something that's a little unique to Substrate. So let's go check out one of the things that I can do with this, the chain upgrade stuff.
Right. So again, kind of wrapping up this thing here that when we have an origin, it's going to be one of these types. And whenever we write a dispatchable function, a function that can be called into your runtime, the first thing we want to do is always check what the origin is that's being called.
Right. Where is this coming from? Exactly. What permission does it have?
Exactly. So you can see a normal transaction. I'm trying to think of, let's go to balances real quick because everyone's familiar with cryptocurrency and stuff like that. So if we go to balances real quick and I look at the function transfer, you can see here that I expect that the call is signed. I expect that some user has signed a message and said they want to do a transaction. And we can, again, uncover who that user is who's calling this message and basically do the transfer on their behalf, right?
Right.
If we go to something like sudo, we have the same thing, right? We're expecting that a user has signed this message and we can know who the sender is, and then we can use that information to check that it is the right key based off of what we have in storage. What we do with this is we actually upgrade it, this origin to a root origin. So we're basically saying if you are this sudo user and your origin is signed, what we'll do is we'll take the same call you're sending to us and change it to a call which has the origin root. And what this allows is that if a function needs root origin, if it needs this basically super high permission, it allows a normal user to then send that message. So let's take a good example of a super powerful extrinsic is a runtime upgrade. So do you want to give maybe a quick summary of runtime upgrades in Substrate?
Yeah, sure. So like with a runtime upgrade, you can basically change out all of the stuff that's in frame. And so like when we started out, we looked at the runtime /src/lib.rs, and where we had this list of like all the pallets that we included. Well, if you change your mind and you don't want those anymore, then you could just upgrade to a whole new lib.rs, basically. And so that's really useful if you want to add like new pallets to your runtime, add new features, or if you find a bug and you want to fix one of those, then you could just go. And there's various ways to like, this way we're going to look at with sudo is just one way of calling this upgrade. But there are lots of ways through governance and whatever custom logic you want really to be able to issue one of these upgrades.
Exactly. So allowing yourself to do a runtime upgrade allows you to quickly iterate on your blockchain, iterate on the logic that's available to it, fix bugs if there are. But basically the main thing is that we allow you to do these upgrades without necessarily having to fork your chain. And,
right.
I'm not sure if this is another topic that you want to cover here.
Yeah, sure. I mean, maybe just like a quick overview, but so like you have like a WASM interpreter and a ahead of time WASM compiler inside the Substrate client. And so if you issue a new runtime, this runtime gets stored on chain and it'll actually execute within your WASM interpreter or compiler, depending on how you set up your node. But it's actually like not running the native client software anymore. It's running the new runtime in this WASM environment.
Exactly. So the key detail about our ability to do these forkless upgrades is that we store the runtime WASM on the blockchain itself. So since it's on the blockchain itself, it is part of the consensus, it's a part of the block production process, that all the users on your Substrate chain are able to come to consensus about what the valid runtime is. And if there's ever any mismatch, let's say that the logic that's on your client is different than the logic that's on the chain, your blockchain will always fall back to use the WASM runtime.
The on-chain.
Exactly. And so if everyone, and of course everyone can always use the WASM runtime and will always come to consensus because that is some fixed piece of code which always has deterministic output.
It's part of the state.
Exactly. And so one of the really powerful things you can do with Substrate blockchains is you can actually upgrade the entire network using this method. Basically, if I were to send a transaction which changed the WASM in storage, something different, then all the other users would be able to sync that new block, would get the new WASM runtime, and their client would automatically be able to start running using this new runtime with new upgraded logic. So this upgrade could have new pallets included on it, could have these bug fixes, could have almost anything that anything you want to change within the runtime itself. And then everyone automatically, without doing any changes, their client just running will automatically upgrade to use this new runtime. And that's a really powerful thing.
Yeah.
But also you can imagine if you were to send a bad runtime or some malicious runtime, that you could basically compromise your whole network, right?
Right. So you want to make sure that this is not just something that you send from like a normal account.
Exactly. And this is where the root origin comes in. This kind of transaction, upgrade the runtime, something that's super powerful. Not anyone should be able to do it. And in the case of our runtime logic, we say only the root can do it. Only basically the blockchain itself can upgrade. So what we have here is we have this function set code without checks. This basically allows us to set the new runtime code. And you can see here the logic is actually very, very simple. The first thing it does, of course, we have an origin parameter, and the first thing we always do is check what the origin is. In this case, we want the origin to be root. If it's not root, this question mark will basically fail, and none of this other logic will process. If it is root, then we do something very simple. We basically put into storage the new code. So you can see here that this other parameter in this function is some arbitrary byte array. And if you're the root origin, we basically just stick into our storage that code, and then we do a little update event. And that is literally the power of runtime upgrades. Like, I think some people expect it to be much more complicated, but literally all we do here is just update the storage item, and all the rest of the craziness that makes forkless upgrades work happens in the client. We can automatically detect that this runtime in the storage is different, and we just use it. Yeah. And so the main thing here is that, okay, we need this root origin to access this function. So let's say that you are you're running some kind of like local test chain. You are a developer trying to test upgrades, and you want to access the change. Well, you don't have access to root calls. Root calls only can happen from within the runtime itself. But what you can do is elevate your permission through sudo. So if you include sudo pallet into your runtime, basically you now have the ability to set yourself as a sudo key. And now you have this function, which is really simple to call, to basically change your transaction, your signed transaction, into a root transaction. And therefore, you could be able to do something like propose a new runtime upgrade through this function with your sudo account, and then it will push it through with the root and basically upgrade your runtime using this function.
Right. So this is kind of like a brute force way of upgrading your chain. Let's look at something a little bit more nuanced, because sudo is a very simple module. It has like one storage item, one event type of thing. Can we look at the new recovery module, and we'll kind of expand on this concept of an origin and what you can do with it?
Sure. So again, maybe jumping just real back, I just want to make sure that this is really clear to everyone, because if we go to system, we go back to this raw origin. When we are looking at the origin coming into our runtime, it can only be one of these options. It's root, signed with some account ID, or none, right? By the time that your runtime has access to this origin type, all of the validation, for example, of a signed message has already been done. So all you get is basically an enum, which is very simple. It just says it's signed and here's the account. We're not actually validating at that point in the runtime that this message was actually signed by this account.
Right, that's been done ahead of time.
That's been done ahead of time, and you just get this object here. So what we can actually do, and this is what we do in this recovery palette, is we can actually do some tricks to allow you to recover your lost account. So as kind of an overview of what this recovery palette does, this recovery palette is basically an M of N social recovery tool. It allows a user who may have lost their private keys, or however they authenticate to access an account on a Substrate chain, to re-access or recover their account using another account, and using basically friends that you trust to verify that it is you and you are trying to access an account. This is very similar to I think like multi-signature wallets.
Yeah.
Yeah.
But instead of aggregating a signature, you're just kind of like following this logic of like, if I get, maybe I have 10 friends and I need 7 of them to sign.
Yes,
then,
exactly.
Then you just, you're not actually validating, you're not actually aggregating a signature. You're just saying, hey, 7 out of 10 people sent this message and they had actually signed it. Like we verified those signatures. So now we're not going to verify the signature on this account that we're recovering.
Yeah, exactly. And it's a little bit nuanced, and I can actually go into that. But yeah, I mean, that's exactly right. So just like a multi-sig would allow, some set of users to maybe, move some money, here we actually take that to the next level, where it's more than just access to funds. It's actually access to the entire account itself. And the reason we can do this is because of this origin trick. So again, in the sudo module that we just looked at, we were able to take a normal signed account and turn it into a root origin. Well, I'm going to show you here in the recovery, we're going to take a signed message from one user and turn it into a signed message from another user. And this is the core piece of how we're able to recover your account. So you can see here, this is the final call that you would make after you go through this process. So the actual pallet itself has a lot of steps in logic, but the final piece that allows it to all work is this asRecovered function, which again is quite simple. It is a function which has an account that you would want to make the call with, and a call that you want to make in general.
Yeah, so the first one is the origin. That's where you're calling from.
Yeah, the origin. Yeah, that's the message you're calling from. This account is the account you want to call with. So like, this is your new account. This is the account you've lost. And you want to make some call. It can be any arbitrary call to any pallet in the system.
Yeah, just for the sake of concreteness, let's just say you want to transfer your money to your new account that you actually control.
Perfect. Yeah, exactly. And this is the call you want to make on behalf using this account. So the first thing we do, of course, is, we always check the origin. We expect a signed message, and we expect that, we want to know who is making the call here. Then what we do is we actually have a simple check here. Basically, we're checking that, and I'll go to this, it's a storage item, that for the account that you want to call, that it has been recovered by this person who's calling. We're basically checking that you have access to make calls on behalf of this recovered account. If you don't, you say it's not allowed. If you do, we dispatch the call. We basically take this call, we execute it, but we use a new origin, a signed origin using the account. And so again, this is a really kind of crazy powerful thing you can do here. So in the role of like a multi-signature wallet, we set up maybe a smart contract. We set up all the users, and they have access to just those funds. But let's say that you have a blockchain account, and that account is not just part of one contract, but part of many contracts. It's has state in multiple contracts or multiple. You have a blockchain with multiple pallets or whatever. And there's a lot of things you might be doing. Like you might be staked. You might be nominating or voting with people. You might be part of a society. All of these things, you would need to set up separate individual mechanisms on each of these pallets to basically access, or recover a system. In this situation, because we have control of this origin, we're able to basically just resend a message, but change who it's coming from. And to our runtime logic, it looks like it is really coming from another account.
Right. And so you could actually have accounts that don't belong to people, but belong to entities like a group. And then you could have different rules of hey, we need maybe 3 out of 5 people on the council to make a certain call, or we need 80% of the general membership of this group to make a call. You can really kind of take this in a lot of directions. And what Joe is alluding to is basically we have these other pallets which are quite complicated like this. They have collectives, we have membership, and these basically allow some unit of people to create an origin on behalf of that group. And these origins can have things like you want to make sure that people in this membership have 3 out of 5 votes to execute some function. But recovery is, again, a little bit more simple. We just have one user. So if we take a look at the declare storage, again, every single pallet has the same structure. So let's close all the declare module. And we go to, up here, declare storage. You'll see here that there is basically a map. So before we had a single value storage item, here we have a storage map, which allows you to map from a key to a value. And basically the map here maps from some account that you would like to access to the user who is able to access that account. And so if you have in this storage, this mapping set up correctly, you will be able to make this call, you'll pass this check, and you'll be able to make calls on behalf of the user. So yeah, let's say that I lost an account, and
the first number one thing, I want to get my money back. I want to get the balances, right? So what I can do is I can basically go through the recovery process, get that storage item set, and basically make a call here to as recovered to send funds back to my new account. Now, of course, something like this is very powerful. It's very dangerous. You need to set it up under a kind of a process which makes you feel secure, and that's kind of what we have here. I won't go into too much details. I think it's a little bit kind of arbitrary how you set up the process. I mean, there's probably a million ways you can design a system. The one we've designed basically allows you to ahead of time pick some friends that you like. And say how many of these friends are needed for you to recover an account. And also we have a delay period. How long must we wait for you to recover an account? Then if you actually want to go and recover your account, we basically say, hey, you need to give us a deposit. You'll return the deposit. But this kind of gives us a little bit of a fee that if you're trying to do something malicious, that we could take that fee away from you. And then you have to go through the process, of course, getting all your friends to say, hey, this is actually the right user. He's trying to recover the account. It's all good. You, as a person who has a recoverable account, is able to basically ensure that other users aren't able to steal your account without your knowledge. What they've done is they've placed a deposit, the malicious user, and if you still have access to your account, there's a function call here which basically says, I think it's remove, close recovery, which basically says you can close the recovery process and just take the funds for yourself. So basically, let's say that it costs, $50 deposit, again, refundable if the recovery is successful, to start a recovery process. If anyone's trying to recover your account, you can basically just take the $50 away from them. And we have this delay period, which basically ensures that, if you want your account to only be recoverable after 100 days, that you only need to check this pallet once every 100 days, and basically you can just keep claiming money for people who want to steal your account, and basically keep your account safe from any intruders.
Right, and this all comes back to the signed origin thing that you can just show, hey, I actually didn't lose the account because I'm signing a message from it.
Exactly. And so, again, this is just one example of kind of a way that we are able to take advantage of this origin, which is a very abstract concept, and have a lot of great power with it. That we're able to do things like take a signed origin, turn it into a root origin, take a signed origin, turn it into another signed origin, take multiple signed origins and turn it into a collective origin, or even, I guess, I'm not really sure you could do anything from, I'm not sure if you would write any logic which you would take a none origin, inherent intrinsic, and change to something else. But you can see here that there's even this concept of the fact that the origin doesn't have to have an inherent origin or like a location where it came from. You can still process and validate those origins with additional validation logic.
Yeah. So I think we covered quite a lot here, the whole kind of code-based walkthrough of Substrate, Frame, and a lot of the support stuff. This is the first video, and hopefully there's more. I think we got like a ton of ideas. Like we could do like a deep dive into Decal storage. We could do like the council and membership, democracy stuff. If people have ideas, please let us know, and we can just keep doing these videos. So thanks, Shawn, for walking through this.
Yeah, I'm glad to help.